Hello, and I want to welcome you to a discussion on linear inequalities. So let's get started. So solving linear inequalities in one variable. A linear inequality in x can be written in the form of one of the following. mx plus b is greater than 0, mx plus b is less than 0, and then you can add the greater than or less than or equal to. The equal to is attached to those as well. Here are the properties of inequalities, addition and then multiplication properties. And it's pretty straightforward, except the one thing you want to note is that the negative, when you divide by a negative coefficient of x to solve for the variable, you are going to have to flip the sign of the inequality. And that's the most important property you want to gain from working with these linear inequalities. So let's go ahead and look at some examples. Let me grab my pen. Let's do blue. So for number 1, we have 2x minus 3 is greater than or equal to 15. So our goal is just to solve for x, as we usually would. So let's work by just adding 3 on both sides of the equation. So when we do that, we have 2x is greater than or equal to 15 plus 3, or just 18. Now solving for x, we have to divide by 2. Now, since 2 is positive, we're going to just maintain that x is greater than or equal to. If 2 had been a negative, we would have had to flip the sign, but in this case, we're just keeping it as it is. So 18 divided by 2 is 9. Now to graph this on a line, first denote the number you're working with. And then usually you want to put the number that's right least behind it, and then to the right of that number, put the number that would come naturally next. So if it's greater than or equal to, you want to put a solid circle over the top of that number. Okay? And if x is in the left of the inequality, then you can just say to yourself, it's going to be like an arrow and go in the direction that it's following. See, it's like an arrow right here. It's telling you to go in this direction. Or you can just say any number that is greater than or equal to 9. So 9, 10, and every number in the positive direction is going to be making this equation true. Okay. Looking at number 2, negative 3x plus 5 is less than 26. To start solving this for x, subtract both sides by 5. So we're going to have negative 3 is greater than, is less than, 21, because 26 minus 5 is 21. Okay, now to solve for x, divide by negative 3 on both sides. Since we're dividing by a negative, we have to actually flip the sign of the inequality. Now, 21 divided by negative 3 will just leave you with negative 7. So, graphing that, we have negative 7, and then the number least would be negative 8, and then the number that would be a little bit greater would be negative 6. Negative 7, and we don't have the equal to in this inequality, so it's going to be an open circle. Since x is on the left side, we can think of it as an arrow, where this is telling us where to point. So we're just going to point to every number that is going to be greater than negative 7. Let's look at some more examples. These look a bit more involved, but we're going to take the same procedures. So with number 3, we have negative 3x minus 4 is less than or equal to 7. Start solving for x by adding 4 on both sides, because it's farthest away from the variable. So when we do that, we have negative 3x is less than or equal to 7 plus 4 is 11. Now we have to divide by negative 3 to get x by itself. Since we divided by a negative, we have to flip the sign of the inequality. So we're going to have x is greater than or equal to negative 11 over 3. Okay, so now let's graph it. You may be a little scared because it's a fraction, but just follow this lead of having a negative 11 over 3. The number that's going to be less is going to be the negative 12 over 3, which we would just call a negative 4, but for this case, let's just leave it as a fraction. And on this side, let's just do a negative 10 over 3. So we're maintaining our counting numbers that we referred to as just 10, 11, 12, making them negative, and then just putting in 3 as a denominator of a fraction, just to maintain our ability to make a number line. Since we have the equal to, just put the solid dot. That means that this will be included in our answer. X again is in the left, so just like an arrow that is pointing, let's go in the direction, making any number that is greater than or even equal to negative 11 over 3, making the equation true. For our final example in this section, we have 5x plus 4 times the quantity x minus 2 is less than 2 times the quantity x plus 3. Let's go ahead and use the distributive property to take this 4 and distribute it across everything inside that parentheses. And on the other side of the inequality, let's take this 2 and distribute it across everything inside that parentheses. When we do that, we're going to have 5x plus 4 times that x plus 4 times negative 2 is less than 2 times x plus 2 times 3. Let's go through and simplify with 5x. Then 4 times x is just a plain 4x. We have 4 times negative 2 is going to yield a negative 8. Less than 2 times x is 2x. And then plus 2 times 3 is just going to give a positive 6. Let's simplify on the left side of the inequality. 5x plus 4x gives you a 9x minus 8 less than 2x plus 6. Let's get all the variables on the left side and all the real numbers on the right side. So let's start by adding 8 on both sides. If we do that, we get 9x is less than 2x plus 6 plus 8 is 14. Now let's subtract 2x on both sides to get it over by the 9x. When you do that, we're going to have 9x minus 2x, leaving you with 7x is less than 14. Now to get x by itself, divide the inequality all over by 7, leaving you with x is less than 14 divided by 7, or just x is less than 2. Now to graph this, let's plot 2, 3, and then let's not forget the 1 out in front. Since there is no equal to involved, we're just going to have an open circle over 2. And since x is on the left, you can think of our inequality as an arrow pointing us to everything in the less than 2 direction. And our final topic for this session will be solving compound inequalities. These look pretty scary at first glance, but they are really not that bad. What you do on one side of the inequality, you have to do on all the sides of the inequality. And all we're doing is solving for the x. We're isolating the variable in the inequalities. So x plus 2 is going to be sandwiched between 6 being less than the quantity, and then we're going to have less than 8 on the other side. So to start getting x by itself, the only step for that would just be to subtract 2 3 times. It's across each part of the inequality. Over here, 6 minus 2 is 4, less than x plus 2 minus 2 just leaves you with x, less than 8 minus 2 is just 6. And that it's as simple as that to solve. Okay, and for number 2 we have 9 is less than or equal to 3x, which is greater than or equal to 12. To get x by itself, just use the simple property of dividing everything by what's beside the x. In this case, it's a 3. So divide everything in the inequality on all sides by 3. So 9 divided by 3 leaves you with 3. Leave our inequality symbol facing the same direction as it was. 3x divided by 3 leaves you with just x. Alrighty, and greater than or equal to 12 divided by 3, or just 4. Okay, and for our last problem, it's a little bit combination of all the properties we've used in the previous 2 problems. 4 is greater than or equal to 2x plus 2, which is less than or equal to 14. First, you want to subtract 2 on all sides to start getting stuff away from the variable. So 4 minus 2 leaves you with 2. Greater than or equal to 2x plus 2 minus 2 leaves you with 2x, which is greater than or equal to 14 minus 2, which is 12. Now to get x by itself, divide everything which is beside the x, the coefficient of x, which is, in this case is 2. So divide all sides of the inequality by 2, leaving you with 2 divided by 2 is 1. Greater than or equal to 2x divided by 2, leaving you with x, which is less than or equal to 12 divided by 2, which in this case is 6. And that is how you solve compound inequalities.